Hey y'all, Miss Harper here for multiplying polynomials. Alright, so this should be the day 2 of our multiplying things. So hopefully you've already watched the first video or you're in class for that. I don't really feel like trying that one, so let's just move on here to our second example. And I'm going to need to erase that. Alright, so again, there's a couple different ways to look at this thing. Basically what we're going to end up doing though is we are going to be multiplying. Okay, so I think using the box method in this particular example is actually good, and it can help you stay really organized. So you can draw your box. Now this is a 2 by 3. Alright, so I have an x and a positive 3 times 4x squared, a positive 2x, and a positive 1. Alright, so I'm going to kind of work these both ways. So essentially what we're doing is the same thing that we did last time, we're just distributing a lot. Alright, so x times 4x squared, we get 4x to the third power. Alright, after that, I'm going to distribute my x again. Now I have to distribute him 3 times up here first. X times 2x is a positive 2x to the second power. Oh, sorry, I forgot to fill these in over here too. 4x to the third. And this one is 2x squared. Alright, and now instead of just distributing it twice, I have to distribute it 3 times. This is a binomial times a trinomial. X times 1 is just 1x. 1x. Alright, now I'll show you guys how I like to organize my stuff here. 3 times 4x squared is 12x squared. So what I'm going to do is I'm going to write that here underneath my 12x squared. And this is a way for me to stay organized. Or again, you can use the box method. Alright, our next one, we distribute the 3 to the 2x. That's a positive 6x. Positive 6x. Alright, and then we got one more thing to handle, and that's 3 times 1, which is a positive 3. 3 times 1 is a positive 3. And then we do the same thing and we combine like terms. So here I like to organize mine this way because then I can just combine like terms kind of straight up and down. So this doesn't have anybody to play with, so he's just going to drop down. How many total x squareds do we have? Well, we have 14 x squareds. How many total x's do I have? 6 and 1 is a positive 7x, and then a positive 3. Alright, if you're going to look over here at the box method, you'll see how diagonally they're going to combine like terms, and then you'll end up here at the same answer there. So whichever way makes most sense to you, whichever way keeps you best organized, this is Miss Harper's favorite way. So you'll see me doing it that way today. Alright, so why don't you go ahead and pause the video and you try out number 3. Whenever you resume, you will see the work shown and you can see if you got your answer correct. Alright, if you're coming back here with us, you can see all the work that I did. Hopefully you ended up here at the same answer. Oh, I see oh no I didn't. Okay. So fun happened here. Our b to the second powers canceled each other out. Remember, that's like saying 0 times b, which is just 0, so he just goes away. So hopefully you ended up there. Pay attention to your exponents and make sure you're doing your exponent rules correctly. Alright, if you would like to try out number 4, please try it out, pause your note video, and then you can hop back on whenever you are finished. Alright, so hopefully you ended up here, and again you can see how I choose to organize my things. You might be doing the box method, and that is a-okay. Alright, just make sure that you combine like terms appropriately. This guy didn't have anybody, neither did he, so I have 3x to the 4th plus 9x to the 3rd minus 23x squared minus 15x, oh my gosh, plus 30. What do you think? Sorry about that. What do you think about that? So that one is just a long, beautiful answer. So get used to seeing things like that. Last example we're going to look at now. Yeah, we can go ahead and try it. All right, you got this. So now we're just going to be distributing So many extra times, all right? But we got this. So let's do this one together. 3x squared times x squared. That is 3x to the 4th power. I'm going to run out of colors. 3x squared times 6x. 6 times 3 is 18. X squared times x is x to the 3rd power. 3x squared times 2. 3 times 2 is 6x squared. Whew, that was the first term. Let's do the second term. 5x times x squared, that's 5x to the 3rd power. 5x to the 3rd power. 5x times 6x is a positive 30x squared. 5x times 2. 5x times 2 is a positive 10x. Now, to be honest, you're not really going to see anything like this, but I just thought I'd challenge you guys, and I think you can handle it. Okay, now we got to get weird one more time. We got to distribute this -1 to everybody. All right, -1 times x squared. That's a -1x squared. So I'm going to line it up with my x squareds. -1 times 6x is a -6x. -1 times 2 is -2. Whoa! Then I can combine them all together. Not too bad. We end up with 3x to the 4th power. You didn't have anybody. I have 23x to the 3rd powers. 30 plus 6 is 36. 36 minus 1 is positive 35x squared. 10 minus 6 is a positive 4x. And then our -2 hops down, and whoa, we did it. High five yourself if you were able to get to that answer. Woo! Last example. You might see something like this pop up on an open note quiz, or definitely maybe on your test. It says, what is the area of the shaded region? So let me give you like a soft example over here. Let's say I said that this is 5 by 2, and this is like a 2 by 1. Okay? And I said to find the area of this region. Well, what we could do is find the area of the whole thing. So 5 times 2. 5 times 2 is 10. The area of the, I'm going to say area of the little, AL, is a 2 by 1. So 2 times 1, which is 2. And then all I'm going to do is take the area of the big one, and I'm going to subtract the little one. Alright, if I distribute my negative, it becomes 10 minus 2, which is 8. So we're essentially going to do the same thing. That's just a soft example for you. Alright, so let's find the area of our big rectangle. So I'm going to say A of B, B for big. So this is 3x times x plus 5. Alright, distribute. So I get 3x times x is 3x squared, and the 3x times 5 is 15x. Alright, then I will do the area of the little one, which is x plus 3 times x plus 2. Now remember, it doesn't actually matter which order you put it in. Up here, I like to put the smaller term first. So now we FOIL, or double distribute. X times x, we get x squared. X times 2 is positive 2x. 3 times x is positive 3x. 3 times 2 is positive 6. Combine like terms. And I get that my area equals x squared plus 5x plus 6. Alright, so just like we did in our other example, I'm going to take the area of the big one, and I'm going to subtract the area of the little one. Alright, so it's going to look a little ugly for a second. Yeah. So here's the area of the big one. Now here's where you have to be careful. I erase all of this over here. Ah. Give me some more space. Alright, so area of the big one minus the area of the little one. Now, since we have multiple terms, we have to put those terms inside parentheses and distribute our negative. So I get 3x squared plus 15x minus x squared minus 5x minus 6, and then I can combine like terms. So the area of the shaded region is going to be, here's an x squared, here's an x squared, 3 minus 1, x squared, I have 2x squareds. 15x minus 5x is positive 10x, and then our minus 6 is just chilling by himself, and this, that would be the area of the shaded region. Okay? Woo! You're done with your notes. Get on to your practice. Good luck.